Hi. Alright, in this video we're going to evaluate this integration by using partial fraction. Alright, by using partial fraction. So as you see that this is the integrals of a rational function. Alright, so and you see that you have to check whether this rational function is it a proper rational function or not. So before you're doing long division, that is very important to double check. So as you expand this, you are getting a polynomial with degree 3, and this is also a polynomial with degree 3, which is not a proper fraction. So you have to do some division, long division. So it means that you have to write 3x to the power of 3 minus with 4x to the power of 2 minus 2 divided by x cubed, right? X cubed minus with x squared. So the degree is of the same, either is same or greater than, so we have to do long division. So by now, so I still prefer doing long division to reduce the numerator. So 3x cubed minus 4x squared plus 0x minus 2, right? I just add a 0x here. So then here you have x cubed minus with x squared. So let's start with a division. So we have 3, we need 3 here. So 3 and x cubed, we have 3x cubed, right? We have 3x cubed. So negative 3x squared. So we carry out some division. So we have 0, negative 4 plus 3, negative 4, negative, negative, positive, right? Negative 4 plus 3, you still have negative x squared plus with 0x minus 2. So further, I think that's the best that we can get, because this is the part of degree already less than the divisor, the remainder. So then this is your remainder. So I can rewrite this fraction in the form of 3x cubed minus 4x squared minus 2 divided by x cubed minus x squared can be written in the form of the quotient, right? The quotient plus with the remainder divide by the divisor. Now the divisor x cubed minus x squared, right? X cubed minus x squared is the expanded form of this, right? So we rewrite to the original one so that we can do the partial fraction later easily. So x squared x minus 1. All right. So then we're getting 3, and we have 3. We can take out the negative, so we have x to the power of 2 plus 2 divided by x squared x minus 1. So now I'm going to further decompose this part here into partial fraction. Alright, okay, let's continue. Just now I have shown you that by using this improper fraction, so I have write it in the proper fraction by using long division. But for this section here, we still further need to decompose into its partial fraction. So it means that x squared plus 2 over with x to the power of 2 x minus 1, I have to further decompose where this is a repeated linear factor. So I can write as a over x, right? A over x, b over x squared. So if you still remember the concept of partial fraction, okay, this is the suitable form for this fraction here. So plus with c over x minus 1. Alright, so then I'm going to find the value of a, b, and c. So then I have to, as a, right? So you have x multiply x minus 1, x, you have x power of 2. Here you just have 1x, right? You just have 1x. So you need x and x minus 1. So it means that the a you should multiply with x minus 1, right? So because the denominator you need to multiply with x minus 1. So for this b, you have x squared, right? You have x squared. So you need to multiply with x minus 1. So b x minus 1 plus with c. As c, you have x minus 1, but you don't have x squared in your denominator, right? So you have to multiply x squared. So c will be x to the power of 2. So then everything divided by x squared x minus 1. Then now you can directly compare this to this. So means that the x power of 2 plus 2 will be the same as ax x minus 1 plus with b x minus 1 plus c x to the power of 2. So then you have to finding the value of a, b and c. The easiest way is to find c first, right? You have to find c first, because if you find c, you have to substitute this 2 with 1, right? Or you want to find b first, is okay, right? If you find a, you can't use 0, you can't use 1, because these two number were getting 0. So if you want to find b, you have to make these two become 0. They have a linear factor, they have a common factor x and x, right? So I have to substitute x with 0. I start with substitute x equals to 0. Then I have 0 plus 2, I have 2. Then here you have 0, right? You have 0, 0, everything will become turn 0. And b, you will have 0 minus 1. And this will become 0 also. So it means that from the result here, I will getting the value of b to be negative 2, right? B to be negative 2. So now I want to find c, because if you find c, there is a common factor here, x minus 1 and x minus 1. If you substitute 1, this 2 will become 0 and you can find c. So the next number of x value will be, I will choosing 1, right? Choosing 1. So 1 square plus 2. So you have 3, right? 1 plus 2. So 1 minus 1, 0. 1 minus 1, 0. So 1 square, so you have c, so c is 3, so easily done, right? Okay, then you have chosen your 0 and 1, so you can also using the method of comparing the coefficient, right? You can using, because this is very simple, without expanded you can see the coefficient of comparing coefficient of x power of 2, right? X power of 2. So you can find out that the x power of 2, the coefficient is 1, right? So on is 1. So the coefficient for x squared on the right will be ax squared, right? Ax squared, and this is ax, you want x squared, so you are getting a, you know, a. So this one you have bx minus 1. So x squared is not here, alright? So there are no x squared here, but there are x squared here, which is c. So it means that a plus c, the total of a plus c, the coefficient have to be equals to 1. And you already have your value of c, right? You have c equals to 3. So it means that 1 equals to a plus with 3. As c is 3, right? So therefore a will be 1 minus 3, you have negative 2. Now done, you have find all the value of, you have find a, you have find b, you have find c. So now you can substitute everything into, okay, you can rewrite this as 2, 3 and write this in the form of partial fraction, where this can be written as 3 minus, alright, 3 minus, in a big bracket, this is your partial fraction, alright, partial fraction of this, which will be a over x, a will be negative 2 over x, alright, negative 2 over x, followed by b, negative 2 as well, right? Negative 2, so negative 2 over x squared, negative 2 over x to the power of 2, right? Negative 2, c, the value of c will be 3, right? C is 3, so positive 3. So you have positive 3 over x minus 1. So very simple, you have already write in a form of partial fraction. So then you can easily use formula to, or basic formula to integrate this. So okay, let's evaluate. So before evaluate, we have to integrate first. So 2, 3. Okay, before integrate, I write all this in the form of 3, negative, negative, you have positive 2 over x, right? 2 over x, negative, negative, you have positive 2 over x to the power of 2, and negative 3 over x minus 1 dx. Alright, now you consider integrate one by one. So I'm going to integrate this 3, I will getting 3x, right? 3x plus with 2 over x. 2 over x is 2 ln modulus x, right? 2 ln modulus x, 1 over x. So 2 over x squared, this is a quadratic. So you can rewrite this as 2x to the power of negative 2 and apply basic rule of integration. So 2 over x to the power of negative 2. So as you integrate, you plus 1. So you plus with 2 x to the power of negative 1. Negative 2 plus 1. Negative 1 over with negative 1. And finally, this one is negative 3. 1 over x minus 1, which is ln modulus x minus 1. So it's integrate from 2 up to 3, right? The limit is from 2 up to 3. Alright, okay, let's rearrange this and evaluate. Alright, okay, let's rearrange this and you will have 3x plus 2 ln modulus x. Positive, negative, negative 2 over x minus with 3 ln modulus x minus 1 from 2 up to 3. So then you know that this will be you taking the limits, the value of this, the function is with the value of this minus subtract the value of this. So it means that okay, 3 times with 3 plus with 2 ln 3 modulus 2 over 3 minus with 3 ln 2, right? 3 minus 1, you have 3 ln 2 minus with then you have 3 minus 1, so 2. You substitute 2, you have 3 2 plus with 2 ln 2 minus with 2 over 2 minus with 3 ln 1, right? So you have 3 ln 2 minus 1, 1. So then you can evaluate. We're calculating all the number without the ln. I add up everything here. I will getting 10 to the power 10 over 3. I will getting 10 over 3 for this as I negative 6 plus 1. So I will getting the value of 9 minus 2 over 3. So I'm getting 10 over 3. So let's look at the logarithm number. So for this you have ln 3 to the power of 2, you have 9, right? Followed by ln 2 to the power of 3, right? 2 to the power of 3, you have 8. So negative, negative, positive, negative, right? So ln 2 to the power of 2. So you're getting ln 4, right? Ln 4. And this one, of course, 0. Ln 1 is 0, right? 0. So then simplify this, you will have 10 over 3 plus with ln. So means that 9 minus means divide. 4 multiply 8 here. Alright, 4 multiply 8. So you will have 10 over 3 plus with ln 9 over with 9. 4, 8, 32. That's your answer. Right, which is exact answer for this partial fraction as I have already evaluated. Or you can write it in the form of decimals if you want. So you can write in the form of 3 significant figures, which will be 4 significant figures with 605. All right, 2.6065. All right. So or you can using calculator in finding the answer for this one. All right. You can double check with this calculator where you have the integral here. Can you see that integral? So then you key in all the value here. You can key in 2 you can key in 2 here. So 2 up to 3, right? 2 up to 3. Then you key in the function. Key in the function exactly as this. So you have 3x cubed, right? So you have 3 alphabet x shift cube, right? Shift cube, then minus with 4 alphabet x square, 3x cubed minus 4x square, negative 2, alright, divide by alphabet x square, right? In the bracket you have x minus 1, alphabet x minus 1. So then you're getting this, right? So you're pressing equal, then you are getting 2.064822008. If you round off, you're getting 2.065. So you can using this calculator to help you in evaluating integral. So alright, let's move on to the next examples in the next video.